Now let's start working with task 3. So here we're given an integral from 0 to 2x to the power 4 dx, and we have to compute an approximation of I using Richardson's method, and we have to use one segment and two segment trapezoidal rule results here. So let's go ahead and start working on this. So here we have the integral is equal to integration from 0 to 2x to the power 4 dx, and we have to work it out for one segment and two segment, the trapezoidal rule approximation value. So let's take the multiple segment trapezoidal rule here. So the formula for that is integration from a to b f of x dx is equal to b minus a over 2 times n, and then we have f of a plus 2 times the summation from I is equal to 1 until n minus 1 f of a plus ih plus we have f of b. So now for n is equal to 1, we will find out the value of our integration. So that is from a's integration from 0 to 2x to the power 4 dx will be equal to, so this here is an approximation, so this one here will be b is 2. So here, as you know, this one here is your b, this one here is your a. So b minus a is 2 minus 0 divided by 2 times n here is equal to 1. Then we have f of a, which is 0, plus 2 times the summation of I is equal to 1 till n is 1, 1 minus 1 is 0. So we cannot go for a summation that starts with I is equal to 1 until 0. That's not possible, so there is nothing to be done here. And then we have f of b, which is 2. Basically, when n is equal to 1, is just the normal trapezoidal rule, where you have b minus a divided by 2 times f of b plus f of a. Therefore this term here is giving you no results, but because I'm applying this in the multiple segment trapezoidal rule, it looks something like this here. But you can just, when n is equal to 1, just apply the trapezoidal rule itself. So we have here 2 divided by 2 times f of 0, which is taking the function x to the power 4, so replacing x with 0, we have 0 to the power 4, plus f of 2, so replacing x with 2, we have 2 to the power 4, and that is going to give us here, so here we have 2 1 times, and we have only 2 to the power 4, which is the value 16. So that's the value when n is equal to 1. And then let's find out when n is equal to 2, what is the trapezoidal multiple segment trapezoidal approximation. So here again, for the same integration, we have b is 2 minus 0 divided by 2 times n. So here our n is 2 now, and for f of a, which is 0, plus 2 times we have the summation from I is equal to 1 till n minus 1. So n is 2, 2 minus 1 is 1. And then we have f of a, which is, so a is 0 plus I is 1. So from, we have 1 to 1, that means we'll only do this one time. That's why I'm not writing here again I. So or maybe I should write so you're not confused. So here we have 0 plus I times h. So h here is going to be, so h for this when n is equal to 2, we have h is equal to b minus a divided by n. So we have b is 2 minus 0 divided by n. Here is 2, so 2 minus 0 is 2, 2 divided by 2 is 1. So h is equal to 1 for when n is equal to 2. So then here we have h is 1 plus f of b, which is 2. So now if you rewrite this, you have 2 minus 0 is 2 divided by 2 times 2 is 4, and here you have f of 0 plus 2 times, here's summation I is equal to 1 till 1, so we have f of 0 plus 1 times 1 plus f of 2. So that is, here we have 2 1s are 2 2s are, so we have 1 over 2 times f of, or let's replace now f with the function itself. So here we have the function is x to the power 4, so replacing x with 0, we have 0 to the power 4 plus 2 times, we have 2 times, we'll have here 0 plus 1 times 1 is 1, so f of 1, and replacing it in the function, we'll have 1 to the power 4 plus f of 2, so 2 to the power 4. So that is, if you calculate, you will get the value as 9 here. So writing it in a table form, so for, let's say, for segments and segments, when we have one segment, we have the approximate value is 16, and when we have two segments, the approximated value is 9. So now we have to use the Richardson's formula, which is true value is approximately equal to AV, or approximated value, which is this one here, the approximated value of two segments plus 1/3 the approximated value of two segments when n is equal to 2 minus the approximated value when n is equal to 1. So it's kind of using these two values here to get the next approximation. So we have here the approximated value when n is equal to two segments is 9. So we have 9 plus 1 over 3 times, again the approximated value when n is equal to two segments is 9 minus the approximated value when n is equal to one segment is 16. So that's 16, and this here will be 9 plus, so 9 minus 16 is minus 7, so this here will be 9 minus 7 over 3, which is equal to 20 divided by 3, which you can write it as 6.6667. So that's the next approximation here. So if you want, we can write it here as the next approximation, which is 6.6667.